Today we'll be discussing material and preparation for section 2.3, which is evaluating some functions and simplifying some complex fractions. So to start, let's assume we have something like f of x equals x squared plus 3x plus 1. We're going to evaluate each of the following. We have seen this before in 124 material, but it's a good review setting up for today's lecture. So f of 2, I see 2 in place of where the x sits, so I want to replace everywhere I see an x with a 2. So f of 2 equals 2x squared plus 3 times 2 plus 1. Well, that's 4 plus 6 plus 1, which is 11. Similarly, we can look at f of 0. So we plug in 0 everywhere we see an x. 0 squared plus 3 times 0 plus 1, which is just 0 plus 0 plus 1, so we get 1. Now if we look at f of negative 1, all right, plug in a negative 1 everywhere we see an x. Negative 1 squared plus 3 times negative 1 plus 1. Well, negative 1 squared is 1. Notice how the negative gets squared with the 1. 3 times negative 1 is minus 3. Then we have plus 1. 1 minus 3 is negative 2. Plus 1 is negative 1. So those three are pretty straightforward. You plug in the number where you see an x, you get a number. Now for this last one, see, we're actually plugging in x plus 2 everywhere we see an x. And so first off, I have x plus 2 squared plus 3 times x plus 2 plus 1. So same principle applies. Everywhere I see an x, I plug in x plus 2. Now we have to FOIL out that first term, and I often like to do that on the side. So an aside, we're looking at x plus 2 times x plus 2, and that's going to be x squared to multiply our first terms, plus 2x to multiply our outside, plus 2x multiplying our inside, plus 4. So in total we get x squared plus 4x, combining those like terms, plus 4 plus. So anytime I have that kind of binomial squared going on, two terms squared going on, I always write it to the side and FOIL it out so that you don't have to try to do all of that in one step. So then we put the combined terms version in place of that first term. Now we just have to distribute our 3. So it becomes 3x plus 6 plus 1. And if we simplify this and combine all of our like terms together, we get x squared. I have a plus 4x plus 3x, so plus 7x. And I have a plus 4 plus 6 plus a 1, so plus 11. And that is it, fully simplified. Moving on to our second example. Notice how we have fractions inside of fractions here. So this is a specific case I wanted you guys to practice. To undo this, I want you to multiply the top and the bottom by whatever you see in the denominator in either the top or bottom. So in the first example, we have a 2 in the denominator, so I'm going to multiply the top and the bottom by 2. But this whole second term is what gets multiplied by 2. So if we do this, we have 8 on top, divided by, and now you're actually going to see that fraction in the second term fall away. So we do 2 times x, and then we do 2 times negative a half, which is minus 1. So just by multiplying the top and bottom by the fraction, by the denominator of the fraction you want to get rid of, you can actually simplify it and get rid of it. Let's look at the next one. You see I have an x in the denominator here that I want to get rid of. So I'll multiply the top and the bottom by x. See this x right in here. So I have 7x on top and I have to multiply this entire thing by x. So I have to distribute my x to both terms. I get x in the first term minus this would really be x over x. And I'm just showing you this kind of with all steps written out, right? I would multiply the first term by x and then the second term by x, and I get x over x. So now I have 7x divided by x minus 1. And that is that fraction, complex fraction, fully simplified. Now, for the last example, notice I have an x in the top, an x in the denominator of a fraction in the top, and an x in the denominator of the fraction in the bottom. So I'm going to multiply both the top and the bottom by x, and you're going to see what happens. I have parentheses here because I have to distribute it to the entire top term. And so here we have again x over x plus 3x divided by 2x over x minus 5x. So everybody gets an x essentially. But now we want to simplify our x's, and we have 1 plus 3x on top. And then 2x over x, well, those x's cancel, so we have 2 minus 5x. So you can see in each of these cases, we were able to reduce the fraction away, just to one fraction at least. This is as far as any of these can be simplified. So give us some practice with the practice problems here. There's several on plugging in and then several on complex fractions. And the answer key is already posted. So please reach out if you have any questions. Thanks, guys.